Absolute value equations work very closely to regular equations. The only thing that's interesting about them is these bars. That's what absolute value bars are, these little things. And they take whatever number they have inside of them and they turn it into a positive. So, for example, if I have the absolute value of a -5, it just turns that number into a +5. However, what doesn't happen is it doesn't just switch the sign. So like if I plug in a +5, it stays as a +5. Also, what it does not do, if you do like this, let's say somebody says -14 plus 4. Now, what it does not do, it doesn't make the -14 into a +14. You do the operations inside of it first, and then whatever you get out, then you apply the absolute value rule to it. So how we do it with equations is very similar. However, you had to break it up into two different things because essentially you can have two separate inputs giving you the same output, right? So I can have a negative and a positive version of the answer that still work. So for example, let's say I do something kind of basic. Let's do -6x equals 30. If I do something like this, again, if these bars weren't there, we know how to solve it. But since they are, it's a little bit weird. What you do is you have to break it up into two separate versions. You're going to break it up into one version where you have basically the same thing you're going to copy and paste. But the second version has a negative version of the other side of the equal sign on it. Because again, remember how I said you can have two separate inputs and get the same output. So we're going to see what that would be. So let's solve each of these little equations. We divide by -6 here and there. And we're going to get -5. So one of our answers that we could plug into here is -5. What if we do over here? We divide by -6, divide by -6, and I get a +5, okay? Now this one just happened to work out to where they're opposites of each other. Now that doesn't always end up being the case, but sometimes it does, okay? So that means I have two separate versions that could work for this. So I could plug a -5 into here and get a 30 out, or I could put a +5 into there and get a 30 out. So again, there's two separate answers because you can put two separate inputs in and get the same output, okay? Let's do one where you have a little bit more work to do before you do the split, okay? Let's do one where you have absolute value of x divided by 7 equals 5, okay? Now we know how to, again, ignore the bars for a second, okay? Because we got to deal with this 7 first. Well, how do you get rid of the division? You get rid of it by multiplying, right? So you multiply by 7 on both sides. So this will just be absolute value of x equals 35. Now at this point, we just have to break it up into two, because once your bars are by themselves, that's when you split up into two separate equations, okay? So I'm going to do x equals a +35, and you're really done at that point. And then x equals a -35. So again, what this means is you're going to have two separate answers, like I said, because you have two separate inputs that essentially give you the same answer, okay? Now notice these have always been, positive, negative versions of the same answer, right? This is like -5, +5, +35, -35. Now that does not always end up being the case, okay? Sometimes you have different values that are not exactly negatives and positives off of each other, okay? And that's what I want to do now. This next one, you can actually do a D word we talked about called distributing if you would like. However, I'm not going to do that just because I kind of want to make sure you get used to always getting the absolute value bars by themselves first and then doing the split, okay? So let's do one like this. Let's do 4n plus 8 equals 56, okay? So now, this one you're going to have two separate answers like I always said, but your answers aren't going to be switch signs like they have been. So you can distribute the 4 in. However, I like to get the bars by themselves first. It doesn't really matter. So I'm going to divide by 4 because again, 4 is being multiplied by all this. So I'm going to divide by 4. This would end up being, excuse me, give me a second, 14. Sorry, took me a minute. Then equals absolute value of n plus 8. Now again, once you get your bars by themselves, now let's do the split. So n plus 8 equals a +14. N plus 8 equals a -14. Because remember, once your bars are by themselves, that's when you can do two separate answers, right? So let's solve each of these. These become basic one-step equations. So I subtract 8 over here, you get 6. Now you're not going to get -6 over here. You subtract 8 over here, and you end up getting n equals a -22, okay? Now they're not the same answer. Now don't get worried though. You didn't do anything wrong at all, okay? You did everything right. Later on when we do stuff, we'll actually go back and check those answers, which I want to show you actually real quick how we do check them, just to prove a point, okay? So let's say you wanted to check these answers. These are always good to check because sometimes you don't always get the right thing happening, okay? So what I do is I go back to the very beginning, and I'm going to plug it into this yellowy green equation up here. So I'm going to test this one out first. I'm going to do 4, and then remember how I talked about the n is always, whatever the variable is always like your blank. So I'm going to put a 6 in there. I'm going to put it in parentheses, okay? So I figure out what that is. 6 plus 8 is 14, okay? Now the absolute value of 14, remember our rule when we talked about absolute values, okay? Whatever the absolute value is, right, it just makes it a positive. Well, 14 is already a positive 14, right? So that'll just stay as a 14. And I just simply say, is 4 times, what's 4 times 14? Well, that'd be 56. And does 56 indeed equal 56? Yes, it does. So that means this does indeed work out. You can use this trick to check any of your answers, okay? Now let's do this one over here. Let's do the 22 just to prove this right, okay? So again, I'm going to basically just write down our equation here, our original one. And you can also do this one up here, but I like to do the original one just to prove a point. And I'll plug in negative 22 into here. You may say, well, how am I going to get even close to the same answer? Here's why. Remember how I told you that the absolute value always puts out a positive version. So the inside of the bars will probably be the same thing as this. It'll probably be 14 as well, but it's probably going to be a negative 14. So let's see. Negative 22 plus 8 is actually negative 14. All right? Had that 4 in front equals the 56. And then look at there. Absolute value negative 14, it changes to a positive, right? This automatically turns into a positive 14. And look at there, it turns into the exact same thing I had before. And 56 does indeed equal 56. And this is a great way to check your answers, just to be sure the left side and the right side match. So absolute value bars really work the same way, except once you get your bars by themselves, you split it up into 2 separate equations and you have 2 separate answers.